Today we're going to look at the derivative of e to the x. So I'm going to take a graphing calculator and I'm going to check and see what it is on the calculator. So I'm going to do y equals e to the x, and I'm going to graph it. I want to look at what the table of values looks like, so I'm going to write those numbers down. So I'm going to write 2.7183, 7.3891, now I'm going to look at what the derivative is at each of those numbers. So I'm going to go back to the graph, and then I can calculate for number 6 the derivative at x equals 1. And I can see that it is exactly the same as the original function. I'm going to try that again at x equals 2, so I want to calculate the derivative when x is 2. And I can see that I get exactly the same answer again as the original function. I'm going to try it one more time. So I want to calculate the derivative when x is 3. And again, I can see that we get exactly the same number as the original function. So the derivative of e to the x is itself its own derivative. It is e to the x. If we think back to the chain rule, when we learned that, when we first started learning derivatives, we're going to use that to help us solve derivatives with e to the x. So it was h prime of x times g prime h of x. So if we look at the function y equals e to the 5x, I can say that the outside is e to the x and the inside is 5x. Well, the derivative of e to the x is just e to the x, and the derivative of 5x is 5. Using the chain rule, I can say that it is 5 e to the 5x. Looking at the next one, the outside is e to the x, and the inside is x plus 1. The derivative of e to the x is e to the x, and the derivative of x plus 1 is 1. Using the chain rule, I'm going to get 1 g prime of h of x, which we can simplify to that. Let's look at a couple more and then we'll see if we can find a pattern. So we have e to the x to the power of 3. So again, the outside is e to the x, and the inside is x cubed. Taking the derivative, we get e to the x. Taking the derivative, we get 3x squared. Using the chain rule, I'm going to have h prime, g prime of h of x. Looking at the last one on this side, outside is e to the x, inside is the polynomial. G prime of x is e to the x, and h prime of x is 10x to the power of 4 plus 4. Using the chain rule, 10x to the power of 4 plus 4 times g prime and then h of x. So using this, we can find a pattern. So if we know that the original function is f of x equal to e and then some function a to the x. A shortcut could be that the derivative is the derivative of the exponent times the original e to the a of x. So we can use that as the shortcut, which will help us if some of the functions are a little more complex. If we look at this one, this is a product rule. It is x squared times e to the x. So I'm going to call a to the or a of x x squared, and b of x is e to the x. The derivative of x squared is 2x, and the derivative of e to the x is e to the x. So f prime of x will be 2x e to the x plus x squared times e to the x. I can factor out an x from both terms, and I can factor out an e to the x from both terms. From the first term, I'm left with a 2, and from the second term, I'm left with an x. For f, I'm going to rewrite this first before I start it. So I'm going to rewrite it as x minus e to the x all to the 1/3. Now I'm going to choose the chain rule to solve for it. So I'm going to bring the power down, rewrite what's inside to a power 1 less high, and then I'm going to take the derivative of what's inside. The derivative of x is 1, the derivative of e to the x is e to the x. I'm going to simplify this. On top, I'm going to have 1 minus e to the x. On the bottom, I'll have the 3, and then I'll have this part here, all squared. Last question is we're going to look at finding the equation of the tangent to the following function at x equals 0. So I'm going to say that a to the x is e to the x plus 3x, and I'm going to use the quotient rule. So b to the x is e to the 2x. The derivative of this is e to the x plus 3. And the derivative, I can use the shortcut now. I'm going to get 2, which is the derivative of 2x, times e to the 2x. So I get a prime times b to the x, minus a to the x times b prime. And this is all over e to the 2x squared. From each of these terms, I can factor out an e to the 2x. In the first term, I'm left with e to the x plus 3. From the second term, I'm left with minus 2e to the x minus 6x. I can cross out an e to the 2x and an e to the 2x on the bottom. And then I'm going to simplify the top. On top, I'm left with minus e to the x minus 6x plus 3. And this is all over e to the 2x. Well, if we recall, it gives us the slope. So m is equal to negative e to the x minus 6x plus 3. all over e to the 2x. We're doing it for the point specifically at x equals 0. So wherever x equals to 0, or x is, I'm going to put 0. Well, e to the 0 is 1. This disappears. And then I'm left with plus 3 all over 1. And this is equal to 2. I need to know what the y value is when x is 0. So I'm going to plug in x is 0 into the original function. So I'm going to do y equals e to the 0 plus 3 times 0 all over e to the 2 times 0. Well, this disappears. And I'm left with y equals to 1 over 1, so y equals 1. This gives me the point 0 and 1. Well, because I have the point 0 and 1, this is also the y-intercept, which gives me the value of b. So if I do y equals mx plus b, I have y equals 2, which is the slope I found, x plus 1. Or I can write it as 0 equals 2x minus y plus 1.